All right, guys. Yep, I'll take it. Thank you. Your note sheet. All right, guys. So the first thing we're starting out is with theorems 2.4 and 2.5. Now, the first theorem that we have is the congruent supplements theorem. If two angles are supplementary to a third angle, then the two angles are congruent. So if angles 1 and 2 are supplementary angles, well, it means that the measure of angle 1 plus the measure of angle 2 is going to equal 180, and that the measure of angle 2 plus the measure of angle 3 also equals 180. Well, we're saying that angle 1 and angle 3 have to be the same angle, because there's only one way that we can add two numbers together and equal 180. Now, the congruent complements theorem is the same thing. If two angles are complementary to each other, that means that the others have to be the same. So if 4 and 5 are complements, it means that the measure of angle 4 plus the measure of angle 5 is equal to 90. And the measure of angle 6 and 5 equals 90. Well, 4 and 6 have to be the same. So if we're really looking at this here and saying that the measure of angle 1 is 80, and it's complementary or supplementary to the measure of angle 2, well, the measure of angle 1 plus the measure of angle 2 equals 180. The measure of angle 1 is 80. The measure of angle 2 has to be 100. Well, if we say also that the measure of angle 2 is complement with the measure of angle 3, they add together to be 180. Well, what is the measure of angle 2? 100. So what does 3 have to be? 80. So 1 and 3 would be the same. That is the same thing it's saying with complementary angles. It's just instead of them being equal to 180, they are equal to 90. Now, one of the new things that we're looking at today is flowchart proofs. What we did yesterday and Friday and Monday, all this week, is two-column proofs. As it has two columns going down, that's a two-column proof. Our flowchart proofs here is kind of a flowchart. It's going to flow from one to the next. So if we do this flowchart proof, we're going to start with the what? Given. Because the given information is that angle 1 and angle 2 are right angles. So that's what we'll start with, is that angle 1 and angle 2 are right angles. So what does it mean if angle 1 and angle 2 are right angles? Now, where are we wanting to go? We want to say that angle 1 is congruent to angle 2, yes? So far we've said they're right angles, and the measure of angle 1 is equal to 90, and the measure of angle 2 is equal to 90. So what can we say next? So what would go from here? Well, what do we know about measure of angle 1? It's measure of angle 2 is? Well, they equal the same thing, yes? So we can set them equal to each other. That's the transitive property of equality. And if two things are equal, it means that they are. Yep. That means the figures are the same. Equals, we're talking about their actual measures, a number. Congruent, we're talking about the figures, so the angle itself. Angle 2. It means they are the same angle in size, dimension, and shape. Everything is the same. When we say equals, we're just talking about their measure. Questions on this here? Okay. So we're going to look at this flowchart proof with proving that angle 2 and angle 3 are congruent. Yes, it is upside down. So, what do we always start out with is the given. Angle 1 and angle 2 are supplementary. Angle 1 and angle 3 are supplementary. Thank you. All right, so let's focus in. Thank you. Now, if two angles are supplementary angles, what do we know about them? What is it telling us? They do what? They're not going to be the same. They add up to be 180 degrees. So if 1 and 2 are supplementary angles, it means their measures add up to be 180. So from that, I can say that 1 and 2 add up to be 180 degrees because that's just the definition of supplementary angles. But also means that 1 and 3 will also add together to be 180 because we were told that they are supplementary angles. Okay, so really all of this here just comes from the fact that we're told that 1 and 2 are supplementary and 2 and 3 are supplementary angles, yes? Well, we're wanting to get to a statement that's relating angles 2 and angle 3, yes? Wait a minute. I have two statements here that are dealing with 1 and 2 and 2 and 3, yes? Do they both equal the same value? So I could set those two equal to each other by our transitive property of equality. So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 3. Well, we do have something extra on both sides because we just really want to talk about angles 2 and 3. But what does both sides have? 1. Can I get rid of it from both sides? Well, yeah, it's just a number, isn't it? Because when we talk about measures, we're just talking about a number, their unit, so I can do what to both sides? Yeah, we can subtract the measure of angle 1 from both sides. Because if it's just a number, we can subtract it. And if two things are equal, it means that they are also what? Congruent. Because we can subtract the measure of angle 1 from both sides by our subtraction property of equality, which tells us that the measure of angle 2 is the same as the measure of angle 3. And if two angles have the same measure, it means that they are congruent. Because that's just the definition of congruent angles. Any questions on this here? We ready for the next one? Copy and complete the flowchart proof, then write a 2-column proof. So, they already filled in the given information for us. AB, line segment AB is perpendicular to line segment BC. And we also have that DC is perpendicular to BC. Well, perpendicular lines or segments meet at right angles. So if they meet at right angles, it's really telling us that angles B and angle C are right angles. They're both right angles. Yeah, why don't we say that too? Because we could say that, or we could say the measure of angle B equals 9 degrees and the measure of angle C is equal to and because they have the same measure, it means that they are congruent to each other. That's it. Any questions on this here? Guys. Now, if we wanted to write a 2-column proof of this, because we can start off with our statements. Well, we would just start off with the given. AB is perpendicular to BC, and BC is perpendicular to BC. This is just our given information. And that's what we started out the flowchart proof with. Our second statement was that the measure of angle B is equal to 90, and the measure of angle C is equal to 90. This is the definition of perpendicular lines. Now, I could add a third step in here and say that the measure of angle B is equal to the measure of angle C by our transitive property of equality. And then we can really just say that the measure of angle B is congruent to the measure of angle C. Definition of congruent angles. But it wouldn't be too wrong to do it the other way either. Because we just added a step in to say that they are equal, so it means that they are congruent. But since we do know that they have the same measure, it also means that they are congruent. So we don't really need step 3, but we can have it if we want it. It wouldn't be wrong to include it. Questions on this here? Okay. Perpendicular lines. Now, as we just saw, turning a flowchart proof into a 2-column proof really isn't that much there, because what are we doing? We're just really just copying over what's on the flowchart proof into 2 columns. Yes? Now, we're not going to worry about this because I'm not going to ask you to do 2-column or 2 flowchart proofs on the test. I'm wanting to show you these here so that y'all can see what they are and kind of see how they work. Okay? Now, we'll write this one into a flowchart proof so we can see how it transfers over. Oh, shoot. Because for us to be able to do this, I'm going to have to create a new slide. Now, when we start off with the flowchart proof, we always start off, or with any proof, we always start off with the given information. Now, the given information for this here is that angle 1 and angle 3 are are supplementary angles. Or sorry, 1 and 2. And that is our given. Because whenever we do flowchart proofs, we'll put the starting statement and then the reasoning underneath. Our other given information was that what? 1, or the 3 and angle 2 are supplementary angles. And that right there is just our given. Now, we're not going to connect these two together because do those actually connect to each other? Example 2. Because, well, the fact that 1 and 2, there should be a 2, are supplementary angles and 3 and 2 are supplementary angles really don't have any impact on each other. But what we know for the fact that 1 and 2 are supplementary angles, it means, well, the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Definition of supplementary angles. And the same thing for 3 and 2. The measure of angle 3 plus the measure of angle 2 is equal to 180. Definition of supplementary angles is those just flowed from the start. Now, and again, they have that right there in the 2-column proof, yes? Because nothing we've done so far has been different too much than the 2-column proof. Now, what's the next statement in the 2-column proof? Well, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2, yes? So we've really taken these two statements and did what? Put them to. So really in this flowchart proof, what we can actually do now angle 1 plus 2. Oh, all right, I'm going to write this first. Measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus measure of angle 3. Transitive property of equality. And that's what's nice. This is what's nice with the flowchart proof is because we can show the flow of how the proof is going. Our givens, they're both supplementary, led to the fact that the two angles add together to be 180. These two separate statements we can combine into one equation. Now we can use our subtraction property of equality to come down to say that the measure of angle 2 is equal to the measure of angle 3. And then because of our congruency, definition of congruency, angle 1 is congruent to angle 3. Because we had our subtraction property of equality and then the definition of congruent angles. But we can show this flow of how one step leads to the next and what is really relating to each other. But the issue is that this takes up a lot of room. It does show how the flow of the proof is a lot better, but it takes up a lot more space than 2 columns. Any questions on this here? All right. Let's look at the last postulate and theorem of the day. If 2 angles form a linear pair, then they are supplementary. Well, 2 angles are supplementary, they do what? Supplementary angles add together to be 180. So here, angles 1 and 2 would add together to be. And that is the linear pair postulate. Now, vertical angles are congruent. They're going to be the exact same. So angle 1 and 3 are congruent. 2 and 4 are congruent. So let's use those properties. So they told us the measure of angle 1. We want to find the measures of angle 2, 3, and 4. So knowing that angle 1 is 117 degrees, what other angles can we find? What is the measure of angle 3? Because angle 1 and angle 3 are vertical angles, which means that they are congruent, so they will have the same measure. What does that also mean about 2 and 4? They're going to be the same. Whatever they are, they will be the same value. Now, how could I find the measure of angle 2 or 4? Yes. Because really what we're saying is that 117 degrees plus the measure of angle 4 is equal to 180. So if we subtract 117 from 180, we get 63. So both angle 3 and 4 are 63 degrees. 2 and 4, yes, thank you. Questions on this here? Okay. Okay, we're told that the measure of angle 2 is 59 degrees. What other angle do we know? 4 is 59 degrees. Well, now we need to find the measure of angle 1 and 3. So I can take 180 and subtract 59 because 4 and 3, 3 and 2, 2 and 1, 1 and 4, any one of those pairs will add together to be 180 because they are linear pair. They make a straight line. So if we type that in a calculator, it should give us 121 degrees. What happens if I add all 4 of these angles together? Yeah, 360. Because if 59 and 121 add together to be 180, these two add together to be 180. So we get a whole circle, which is 360, yes. So when we do the subtraction, we'll start at the 0. Because since I can't do 0 minus 9, I'll borrow 1 from the 7, which will give us 10. Yeah, and we could do 121 plus the 59. 0, carry the 1, 5, 180. Any other questions on this here? So let's just work this one through. If angle 4 is 88 degrees, 88. Angle 2 would be 88 degrees. Well, so we're going up to 180, because if I add 2 to 88, I get 90. And 1 plus 9 is 18. Okay. Yeah, or we can do 180 minus 88, which would give us 92. Any questions on this here? We ready for the next one? Yeah. Find the value of x.
Why do they have to throw letters in there? Why can't it just be the same thing?
It is the same thing. What do we know about those two angles? What do we, guys? Logan. What do we know about these two angles? They are what type of angles? Yes. They are vertical angles, yes? So it means those two angles are congruent. They're the same, yes? So TPS, try again, TPS and QPR are vertical angles, just like we had in the previous one.
Well, 148.
So,
It'll be the exact same side. They're equal.
so like this here, 2 and 4 are vertical angles, so they are congruent, yes? 1 and 3 are vertical angles, so they are congruent. So when we look at this here, the whole angle, TPS, which has 148 inside, would be congruent to QPR, this angle here. So what we're saying is 3x plus 1 is equal to 148. So the whole angle for both of those would be 148 degrees. So if I want to find the value of x, we can really just set it equal to. And then what would we do first? Subtract 1 from both sides. Equals.
Can you explain what I'm answer? We did this all last year. Yeah. And I paid attention then? Exactly.
Any questions on this here? Tyler? Any questions on this here? Let's look at one last one. So this one here, they tell us that one angle is 5w plus 3, and the one opposite it is 98. Well, these two are vertical angles, so they will be congruent. So what we can say is that 5w plus 3 is equal to 98 degrees. So what would we do next? We can subtract 3 from both sides, which tells me that 5w is equal to questions on this here. Now, if they didn't, guys, say they didn't give me 98, say they gave me 2w minus, let's say, plus 17. Wouldn't it be the exact same thing? We just set them equal to each other and then solve for the value of w. But that's it. Now, you're probably noticing at this point a lot of what we've done so far is 1 or 2 steps geometry and then algebra the rest of the way. The only thing that we've really done that's been 100% geometry all the way through is our proofs. Those are the only things that we're doing geometry all the way through. And that is it. So your homework is on page 103, 3 through 5, 7 through 10, 12 through 13. Well, you can say 12, 13. Does it really just make any difference? Not yet.
Go back to the. Yeah, that one. Let's just throw a random number in here because that would be 82, and that would be 82, and
Yes.
that would be 98.
Yes. Yeah.
Point proven. How do you come? What's 19 go?
Do 5 times 19 plus 3. Plug in 5 times 19.
Okay. 5 times 19.
Enter.
3.
Yep.
Okay.
What do you get?
Well, why would they do that?
Tyler, pay attention and listen.